The experiment performed was designed for testing the different toughnesses of 3 different materials under the IZOD impact tester. The impact will break the material and the indicator will show the force of the impact. After reading the indicator, students can use a protractor to measure the pendulum's arc height after impact.
The one piece of equipment used was the ISO impact testing unit. The ISO tester pendulum's arm with the set weight at the end. The arm is dropped from a set height and is swung into the test piece. The absorbed energy and angle of rise are read out on the scale mounted on the front of the tester.
The 3 materials that were used during this experiment were brass, steel, and aluminum.
First, we measured the samples with a vernier caliper. To perform this test, first we have to start by zeroing the scale. We then lift up the pendulum and put it in stop. You loosen the vise, take your sample piece, and use the gauge to make sure the sample is in correctly. Tighten the vise to secure the sample piece in place. Further tighten with the large Allen key. Pull the pendulum arm up until you hear a click, and let it rest slowly. Close the protective door. Take pin from pin slot 1 to pin slot 2. Pull the lever to release the pendulum arm. Take the pin out of pin slot 2 and continue pulling the lever to break. Put pin back into pin slot 1. Use the protractor to measure the angle of rise. Push back the pendulum arm onto the stop block. Loosen the vise with a large Allen key. Keep your finger underneath the sample piece while you loosen to prevent the sample from falling into the vise.
After careful analysis of the results compiled from this lab, it is clearly visible that material toughness is a high importance physical property to consider when dealing with the object that suffer impact. From the examination using the pendulum's machine, materials having low absorbed energy are not very tough as they rupture almost instantly and thus turn brittle. From the result, aluminum absorbed the most energy while brass absorbed the least amount of energy. Thus, it may be concluded that material made from brass will more likely fail during impact and materials made of aluminum will success. This is as expected as due to prior knowledge about the property of the materials. What we have found when we are conducting this experiment was resistance between the 3 metals. We found that the steel was stronger than the aluminum and the brass. The aluminum and brass almost the same numbers, showing that the steel was significantly stronger to the brass and the aluminum. They performed this experiment to see if the material durable and strong. In real life, people want materials that are strong, not brittle. For example, when building a big structure, they want steel beams to be able to last a long time and be able to support weight. By conducting this test in real world, we will be able to tell if the material worth using. Another example would be building a school. We want material not to collapse where it would cause serious injury and damage to people. This would result on a lot of people losing their jobs.